Please find page 47 in your textbook, but you may have already cut it out and put it into your interactive notebook, but we have not yet talked about it and taken notes on it. So, fifth hour, we got a little bit behind, but all the other hours, we put this into page 3 called domain and range. But I'm not worried about where in the order this goes as long as we put this entry in as domain and range. And you can trim this down a little bit, but I'd like you to take notes. And I'm hoping that this note activity will help clarify what the work you did yesterday on Desmos. So just as a reminder, when we're talking about domain and range, for domain, we're talking about all the x values that a graph touches or spans. And for range, we're talking about all the y values. So when you are just given a table of input output, domain and range is pretty easy to just list them out. So in this case, the domain would be the numbers 1, 2, and 3, and the range would be the numbers 6, 7, and 8. We just have 3 ordered pairs, so there's 3 elements in the domain, 3 elements in the range. But when we look at a graph we that is continuous, meaning not dotted or discrete, we want to look at how the entire range that the graph spans. Okay, so let's take a look at this graph first. And the best way to think about domain and range is by looking at kind of the shaded region. So with one color highlighter, can you please add these lines? So if we're talking about domain, we want to kind of box the graph in on the x-axis. So the lowest point to the left that this graph hits is -7, and the highest that it hits is +6. Now, the reason I made this a solid line is because you notice this endpoint is solid, meaning we want to include the point -7. But when we get up here to 6, notice that this endpoint is an open circle, which means we are not including +6, but we're getting all the way up to it. But as soon as we hit 6, we don't include it. So once we draw those boundary lines, it's easier to see that this entire span of the x-axis is what we would call the domain. So if you look down here in words, we would say the domain is all real numbers greater than or equal to -7 and less than 6. And it would be written as an inequality like this. Notice that when we want it to be greater than or equal to, we have this line here. And we want it to be just less than 6 when it's an open circle. Notice we don't have the equal to part. So this right here is when we have a closed circle. And just that symbol without the equal to part is what we do for an open circle. Okay. So now for the range, we do the same thing. And if you can grab a different color of highlighter, the range, we want to box in on the y values what this graph hits. So the highest it hits is up here at 8. The lowest it hits is at -2. So on the y-axis, it's everything from -2 all the way up to +8. So over here, we would say the range is all real numbers greater than or equal to -2 and less than or equal to -8. And the inequality symbol would look like this. And notice that it's greater than or equal to and less than or equal to. So both of these symbols have the equal to component. So if you look back up here, notice that up at 8, there's a solid dot, meaning we want to include 8. And down here at -2, there's a solid dot, meaning we want to include -2. Okay. Now, notice when you have these compound inequalities, that the variable always goes in the middle, and these two symbols always point in the same direction, and they're always going to point in this way. Okay, so if you have trouble knowing which way to do that, it's always Y, and then the symbols are always going to look like this, with the lowest number on the left, the highest number on the right, and then you can decide if it should be closed or open, depending on if you need the equal to symbol. Okay, so let's look at the next graph. And notice the next graph has arrows, meaning that it's not going to stop, it's going to continue in both directions. So if you can imagine, this graph is going to keep going out here, keep going out here. It's going to continually widen all the way out. So it's never going to stop on the x-axis. So we would say the domain is the set of all real numbers. And one way to write that is to say from negative infinity all the way up to positive infinity. Notice in all these inequality symbols, the inequality signs are all pointing in the same direction. And the reason we don't put a line down here is because that would mean greater than or equal to negative infinity. And technically, you cannot ever reach infinity. So, how could you ever equal it? So, they always just leave those as less than symbols. Okay, so now for the range, we do our lines again. Notice that this goes all the way up to 8 on the y-axis. But if you go down here, this is going to continue forever and never stop. So it's going to be all y values from 8 all the way down to negative infinity. So the way we say that is the range is all real numbers less than or equal to 8. And we would write it like this. You technically could say this as well. You could say y is everything greater than negative infinity and less than or equal to 8. But typically, mathematically, if we just want everything from 8 on down, they usually leave this portion off. But that would not be wrong to write it that way. Okay, so what I'd like you to do now is I'd like you to make sure this entry gets put into your notebook. And then you are going to return back to the agenda and follow what it says. If you have one of the Desmos activities to finish, you need to do that. And our goal this unit is to be able to take a graph like this and draw your boundaries and identify the domain and the range.